Hi, this is a video tutorial for the River Meander Migration Modeling in the iRIC platform, and this is video tutorial number 4. It's entitled Calibration, a first example using a polygon erodibility map. Okay, in this tutorial we're going to start the calibration of a model scenario by making what we call an erodibility map. This map can be spatially varied, and it's an erosion field that allows the river to meander at a variable rate depending on the erosion coefficient at certain places in the land surface. In this particular tutorial we're going to make what we call a polygon erodibility map. This is one that we can make directly in iRIC, which is great because making them in GIS is a more complicated prospect. As you will see, the method is entirely dependent on making polygons, hence the rather obvious name of the map, a polygon erodibility map. Okay? In order to calibrate, of course, we need two time periods, the beginning and the target, which were the subject of a previous tutorial. And as usual with these tutorials, my main goal here is to show you how to use the tools. In this particular tutorial, my specific goal is to show you how to use the polygon erodibility map tool as a way to begin to calibrate the model. This particular tutorial will not take you completely through calibration, but will show you the first step. And it'll introduce you to a very important tool. Okay, because we want to make it easy, we're going to look at a single bend. So, first step is to set up the background erodibility, which will be the default of the entire land surface. And if you hang on just a bit, we'll get to something more interesting than this slide on the screen. First of all, the first thing we're going to do is bring a target center line into iRIC, and I'll show you how to do that. I won't explain it very much because I expect the way that we're doing it will change soon. Then we're going to set up the erosion grid, and finally, number 3 here, we're going to adjust what we call the coefficient of friction, which again I will explain more. Again, before we get to it, a little more background. As a review, when we get into iRIC, we're going to look at the dialog boxes that actually make iRIC work and make the Meander migration model work. We've already taken the steps of when we get into iRIC, we'll have georeferenced everything, we'll have loaded up our center lines, and we'll have the flow parameters already in there, again subjects of previous tutorials. I'll start by loading up the target center line, and as a little bit of a review here, we're going to use the computational dialog box, number 1 there, and we're going to use 2 new ones, the adjusting the coefficient of friction, CF, and the erosion algorithm factors, number 7 there. We'll continue to use the output, which is quite critical. Okay, here we go. Now, the first step, load up iRIC. And I'll take this project, which I've already set up. There we go. Now what you'll see on there is the 1942 center line. And the first thing is, let's go get the target that we're going to be calibrating toward. The way we do that right now is we have another file all set up. It's 1987. Remember, that was the target that we chose. It tends to come in this format. Now, just let's go look at the calculation conditions. And I found it always useful just to review them all. The starting year was set up on here previously when I was running it earlier today, so it goes from 1942 to 1987. You'd have to set that normally. Okay? This one's not working at this point. The flow values are the ones that we entered before. The smoothing are the default values. We haven't touched that. Coefficient of friction, make sure it's set to 1 to begin with. That's where you should always begin. Okay? Then we go to the erosion algorithm factors. And this has already been set. Normally when you find it, it would be on fixed FD like this. But polygon erodibility map is what we want because that's what we're going to make. Okay? Okay, there's many different ways to work with this. And what I'm going to show you now is an important one to know. Cutoff parameters stay the same, the bend parameters stay the same. This calibration is not working at this point. And the output. Now it's always important to set up the output. Okay? Well, I've got a particular way that I've been doing it here, and that is I've got a folder called output. And what I like to do is I like to go take one, I'm using version 1 here. That's an old output file. I want to copy the name of that output file. Then I create a new folder, and this is version 1, and I will call it video. Now, I happen to know that the coefficient of friction is 1, and the very first erosion that I'm going to use, which is traditionally called E0, will be 300. That's the default we have used in the past. Even though we're making an erosion polygon map, we're going to use the same one. Okay. This has been set. The UTM has been set before. So we save and close. Okay. Here we go. So, let's see where we are now. We're ready to make the erosion field. And the focus of this is to make the erosion field in iRIC itself. So, you go up here under the object browser, and you'll see under geographic data that you have both erodibility and riprap. Okay? Erodibility is where we're going to do all our work. Now, as a sidebar, you'll also see that riprap as a parallel possibility. But at the current time, it doesn't work. But dream about it. But don't expect it to work now. Currently, if you're going to input riprap, you're going to have to do it in the erodibility section, and you're going to have to draw polygons to simulate riprap. Okay. Well, you click on erodibility, and you go add polygon. This gives you some information, tells you how to do it. Define your polygon by mouse clicking, and, very importantly, finish defining by double-clicking or pressing the return key. Make sure you do that. I've spent a lot of time completely ditching things and redoing them because I didn't do that properly. So make sure you finish like that. Okay. Now, I want to make sure I get the whole center line that I'm going to be modeling. So I'm going to move out a little bit, like that. I've got my crosshairs now. Click. 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 Double click. Okay. It immediately tells me that I want to put in an erodibility factor. Now, we start with 300. That's been a default. It's not a very good one, it turns out, but I think it's good to have something that's not so good to begin with, so we see how we iterate. Okay. Well, we're pretty much ready to do a run. We have our erodibility set. Now, one important thing is to give this a name. So if you're here and you right-click on it, you can edit the name. And a good name for this would be something like background. Okay? Let me do that. Background 300. or you might even go background E0300. Make it very clear. Okay, although I didn't spell it correct. Okay, background E0300. Now, I will show you that you can actually save this too, so you use it in the future. Go down here to export, and what I've done is I've set up places where I can save this. So I'm going to save this. First of all, what I do is just take the exact name of it, Control C, export, erosion fields, Control V, save. Okay, if we ever want to use the exact same one again, it's there. Now, we're ready to run. Okay, let's do a run. Now you need to save this a second time before you get on with it. Now here it will ask you if you want to save the project, and it's important to save it or it doesn't run correctly. Okay. Now we see our output. There's the output running at 300. Now what we notice is that it hasn't gotten anywhere near to the target center line with our calibration. So 300, it's too rough. It's too much, too much resistance. So we might guess that something else would be better. Okay? Now, before we go ahead and run something else, what I like to do is I like to take that output before we lose it and name it so that I can view it in my GIS. Okay? Now, let's go look at the output. Here we have the output. A lot of output, as you can see. It's one of the reasons that naming things is important. This is all the output that I have for that. But what we just did was, right there, video. Okay? Now, what I like to do here again, keeping track of the names of things and what they are is important. As you can see, I might have 40 or 50 different runs. If I don't have them named, I'm going to be lost. So I usually copy the name of the folder before I do anything. Okay? Now, here's QGIS. Let's see. And I'm going to bring that output into QGIS. So I'll show you what I'm doing. I go into output. There's the video. I look for the final center line, 1987. Open. Now, before I do anything else, the name that I had copied, I'm going to put right in front of it. There it is. An extra R. Okay. Now I know exactly what that output is, and I always do in the future if I ever have to come back and look for it. I like to format this output a little bit so I can see it better. Just to let you see what I'm doing. Stream, transparency, apply. Okay. So there we have the output that we just generated in iRIC. Now, let's generate some more output, okay? Now, what we'd like to do is we'd like to change the background erodibility. We had it set at 300. One easy way to do that is to edit the value right here. Erodibility 300. Let's set it for 50. The larger the number, the rougher the surface, and the slower the migration moves. So if you have a smaller number, migration is faster. Okay, let's try 50. Now, I want to edit the name. 50. Make sure that I have that 50 value again. There it is. And I'll export this for completion's sake. Forgot to save the name. This is where I copy it. Control C to copy the name. Then I export into my erosion fields. There's the name. I save it. If I ever want to come back to it or have any question what it was, I can find it like that. Now, you might as well check the calculation condition again. Never hurts. 42 to 87. Nothing there. Flow are the same. Smoothing. Coefficient of friction is still 1. We still have polygon erodibility map, and it'll be a new one. It'll be the one with 50. Cutoff parameters, bin parameters, output. Excellent. We need to change the output. Okay. Again, I'm saying rename, but really what I'm doing is I'm just copying that. Control C so that I can make a brand new output folder. Control V. And I know now that I'm going to be using 50. I'll put 50 in there. Okay, calibration doesn't work there. Save and close. Ready to run. Yes, we want to change things. Thank you. Yes, and yes, we will save. Excellent, it's running. And we'll take a quick look at it here. And if you can remember, it has moved a bit. We won't trust our memory. We are going to go back to QGIS and plot it. So let's bring it in. Okay, now just to show you, there's the video part with this and 50. I do this just to grab the name. Control C. The last of the years. I open it. I'm going to copy the name before I forget what it was. And there it is. Looking more like a stream with a different color. Okay, so we see that this was the meander migration with 300. This was the meander migration with 50. So we're more into the ballpark, and that was a useful move forward. We see that the pattern is kind of flat and not as loopy. That suggests to me that we might then go the next step, and that is explore the coefficient of friction. Okay? This is something we just have to get used to. There's two ways to adjust the migration. One is by changing the actual erosion field value. Another is by adjusting this coefficient of friction. We can discuss the details of this coefficient of friction in another tutorial, but suffice it to say that when you increase the coefficient of friction, you decrease the velocity, but not linearly. related linearly. It has a different effect than the erosion factor, and it actually affects the sort of pattern of migration more than the erosion factor. So, from my own experience, I know that we will stick with this erosion field of 50 for now, and we'll explore what happens when you change this. You double it, and you put it to 2. Okay? Now, we have to change our output. Always. Again, I grab the name by Control C. I make a new output file. And everything's the same except the coefficient of friction, which is 2 in this case. Okay. Now, we'll save that and close, and we'll do another run. Now, visually, can we see a difference? We can see a difference, but let's go to QGIS again just to make it clearer. Okay? Now, we're going to go import. One we just made. So this would be a video. This would be here. Oh, that green's too much like the other one. Let's do it. Okay. Let's turn off some of these now. Now you can see the last two that I did, changing the coefficient of friction had that much difference to it. It slowed it down, it didn't move this way as fastly, and it moved like that. Now that I see that, the next thing that occurs to me is we could try adjusting the erosion field one more time and make it erode even more quickly than it has there, which would be taking it from 50 to 30. Let's try that. Okay. We'll go back. We'll edit the value, and I'm going to go rather quickly this time, without much commentary. You've seen me do it in the past. There's 30. There's 30. Now I'm going to save it just as good form. Now remember, my coefficient of friction is 2, my background is 30, and I need to change my output. If you forget that, you're going to go on top of the last one you did, and you're going to lose some of your old output. Oops. Okay, now what do we have here? We have coefficient of friction 2 and our E sub O 30. Okay. Save and close. Let's run this thing. Now it's running. Aha! You can see that it moved down even further. But just to be clear, we're going to look at it in our GIS. Let's turn some of these off for the moment and bring in the one we just made. Whoops. Go into our output. We coefficient of friction, that's the one. We grab the name. Go in there and get our last year. Bring it in. Immediately rename this with the name that we got, so we know what we're doing. Make it a little bit pretty. Okay, I'm not going to worry about color. There we go. Okay, how did that compare to the last one we had? That's one of the values of having these here. Our last one was at 50 with a coefficient of 2, and this one is at 30 with a coefficient of 2. And you can see it's getting better and better. It's getting closer to the other one. Now, this is where I'm going to end this process of calibration. There's more to be done, but I'm going to do that in the next tutorial. We've gone a long ways here, and we've learned how to use that particular box where we make an erodibility grid in iRIC. What we're seeing here is that let me go back. There's 1942. Let me turn everything else off. What we're seeing here is that our calibration here is swinging way over here, whereas the actual, that's the dots, the actual one stays here. So we see there's something going on that we need to do. And that will be the subject of the next tutorial. Okay? Let me do a little bit of a summary here to tie things up. We end our tutorial on using the polygon erodibility map to create an erosion grid. We started with the georeferenced center lines, a beginning year, a target year. We used the dialog box for putting in computational values, and in particular we used the coefficient of friction, and we used the erosion algorithms box in order to use the to make the erodibility grid, the erodibility polygon. And what we dealt with this time was a background erosion value and the coefficient of friction, and we balanced the two to get the model to run as close as possible to our target center line. As you can tell, there's a lot of iteration that goes on to do this. This is just the very beginning of that kind of iteration. And we've gotten closer to what we might call a calibrated model. We're not quite there yet. And that'll be the subject of the next tutorial. Okay, thank you.